All right, today we're going to do something special for a couple reasons. One, because I'm going to try a new puzzle type that I've never done before, never heard of before until last night when I saw it on this website. So I get to try something new, probably stumble through some of the logics, probably mess up some easy stuff at first. But the other reason it's special is because this puzzle comes from, pull up the site, here we go. This puzzle comes from Puzzles for Progress, a website by Jacob Cohen, who posts puzzles every week, I believe. Every week he posts 3 or 4 puzzles. There's a whole bunch on here. This looks like it's week 40 already. So lots of puzzles on here, lots of different types. There's Kakuru and crosswords and heteromino and enclosures. I mean, most of these I've never even heard of before. Crosswords, capsules. There's some spiral crosswords, which are really weird. I might have to do a video on some of those soon because those are kind of fun. But the reason it's called Puzzles for Progress is because he's posting puzzles and he's asking people to go donate to Nothing But Nets, which is an organization that is raising money to supply mosquito nets for people that are at danger of dying from malaria. Um, so we have mosquitoes here in the summer. I hate mosquitoes. They drive me crazy. I am not at danger of dying of malaria. Not very high danger of dying of malaria here. Very low risk. Um, it's just an annoyance for me. But there's people that die all the time from malaria. And so it's a cool idea to post puzzles and just ask people to donate a little bit. He's raised $1,500 already. Um, Looks like he's got a goal of 1,800. Maybe we can push him up that extra 300 and get him over the his goal there. But it's a great cause. You know, saving people's lives. What could be better than solving puzzles and saving people's lives at the same time? So it's a win-win. So go check out his site, solve some puzzles, donate to Nothing But Nets. I'll leave all the links in the description. If I can put a link, if I can figure out how to put a link on the screen here, I'll do that as well. On this side probably. But find the links; they'll be in the usual places. Check out his site. When you go there, you can click on the week's puzzles, and you'll find a little explanation, the rules, links to where you can solve them online. You can also just click on here and pull it up as a PDF, and solve it pencil and paper if you want to. I'm going to be solving on Penpa today. There we go, Penpa. So just a little bit about how to use this if you haven't used Penpa before, and I'm definitely not an expert on this site. There's a lot of different things you can do. I'm just going to use the surface and the colors. You can choose different colors here. Click, and if you click again, it gets rid of the color. And if you right click, it does green. There's probably a way to change what the right click color is, but I'm just going to go with green. I don't really care. That's fine. We'll just do gray and green. So that's how you use Penpa. I've got the first one pulled up here. This is so there's an easy, a medium, and a hard. So we're going to do them in that order. So hopefully I can ease into it and figure it out. So I looked at the rules, and it sounds kind of like Star Battle, if you've done Star Battle before, but with a twist. So the rules say, place circles so that each cage, contains exactly the listed number of circles. Circles can't touch, not even diagonally. Also, each circle should reflect over the gray dashed line in the center to another circle or itself. So, it's kind of like Star Battle then, in that, you're putting, essentially stars. This says circles. We could do circles, but the problem, you can go in here and do shape and circle if you want to. But then you can't do the right click for the other color, or at least I don't know how to do it. There's probably a way to do it. But in the way I've got it set up here, I can left click for gray, right click for green. So that way I can mark, stars or circles and spaces that can't be stars or circles. So in Star Battle, you can't have 2 stars that touch each other like this or like this. So It's similar to that, but we've also got this thing about reflecting across the line. So I guess that means if you have one here, there would have to be one over here as well. So let's start our timer here. So there's this symmetry thing. And normally in Star Battle, you're putting the same number of stars in each region. But in this, there's numbers. Oh, wow, this one over here has to have 10. This one can't have any, so we can mark that green. Which green is going to mean there can't be I'm probably going to call them stars because it's similar to Star Battle. So I believe the rules say to put circles in, but and we actually have an example I've put on the screen here too, so you can see kind of his example. So that's interesting. In the example, there's one that's on the dashed line, so that one wouldn't have a symmetrical partner. Okay, so maybe we can do some stuff with counting, because if there's one on a dashed line, it doesn't have a partner on the other side of the line because it's its own partner essentially. So we've got 4 for sure that are on the left side here. And there's, well, this one has 2 up here in the top. And I was going to say there's at least 1 on the left side because you can only have 1 on the right side. But again, we could have 1 in the middle. We can't have 1 in the middle. Okay, so here's where we can use some of our Star Battle logic. Right up here in this 2 region. So because putting a star or a circle eliminates all the cells around it from being circles as well. You can kind of think of blocks of 4x4 blocks. So like, I'm going to choose a different, I'm going to use yellow for a second. This 4x4 block, you can only have 1 circle in that 4x4 block. There's no way to put 2 of them in there, because if you put one, anywhere you put one, it's going to eliminate the other 3. So essentially we can say there's 1 circle in here, and we have to have 2 in this region. So there must be a circle right there. That has to be a circle, or I'm making it a dark gray. So now that means these 2 cannot be. We're going to eliminate all this whole region. So now there's 1 in one of those 2, in that yellow domino there. Now if you get a star eliminated, or a circle narrowed down to just a domino like this, you can mark the 2 on either side as not circled, because either place you put a circle there, it's going to eliminate both of those. So now we're narrowing down this region over here quite a bit. But you've still got, I mean, you can't do these 2, but you could do any 2 of the 3. And you could do one of these 2, you just can't do both of them. So we could do here and here. There's a lot of options here. So but here's where we use the symmetry argument. Okay, right, because okay, this is what happens when you have a new puzzle type. It's going to take me a minute to figure this out. So we've got a star right here, or a circle right here. So there has to be one right there because of symmetry. And so now we've limited over here, but we can also, not only can we do the symmetry with the where the circles are, but where we can't have one, there can't be one on the other side. So now that's all symmetrical, but these 2 are going to have to be here. We can mark all of those, and by symmetry, we need to have these over here. Okay, I got to make sure that when I mark something green, I also mark its counterpart green on the other side. So now, this is where Star Battle logic doesn't help. Normally, you'd look at this and say, oh, well, I need to have 2 in this row, but there's no rule about having a certain number in each row or column. So we can't use that. But what can we do? Okay, this one needs 4. Let's go back to our yellow. So we can say there's only 1 in here. I see. Okay, so let's actually do just to make this point, I'm going to do red and blue and make this one purple. Okay, so the purple is the overlap of the red and the blue. So we can have one circle in the blue, one circle in the red. And they share a spot right here. But the key thing is we can only have one in the blue and one in the red. So the blue and red together can only have two. A maximum of two. And we need four, which means the only two cells left have to be circles. So now we need to fill in the counterparts, and now we only have one in the red, so we have to have one in the blue region there, which is going to let us do all of that. And now we only have one left for the red. Perfect. Okay, now what's left? We need two in here, but there's quite a few options there still. Now what I can say is there's... Oh, I can't. Never mind. I was going to say there's definitely going to be one on here because we can only put one down with it's the counterpart, so two. So let's see, the 10 region. How many are in the 10 region right now? 1, 2, 3, 4, 5, 6. So we need four more, which is going to be... So we can't put one right here because we need four across the bottom. And if you put one in the middle, you're going to have two and one, and you got to have the counterparts. So we can't put one in the middle there. So we need one in the yellow and one in the red. And those yellow pills mean we can do that. And so now with this two, we need two in this region in the middle. They've got to be those two, which aren't going to have a symmetrical counterpart. But this one down here is going to eliminate those, which gives us that in the yellows. And there we go. I think that is the solution for the easy one. All right. It's like Star Battle, but not. Okay. All right. Now let's pull up the medium one. And start our timer. Okay. What can we do? Well, there's one in here, so we can mark this one green, because no matter where we put the circle in the one, it's going to eliminate that cell, so we can eliminate its counterpart. Now the 2 over here is getting restricted quite a bit, but I'm not sure. There's only 3 options in the 2 cage right now. You've got the yellow domino or these 2 up here. But I'm not seeing how... Oh, of course. Right. So let's look at the blue cell here. If we put a circle in the blue, that's going to eliminate all 3 of the other options in the 2. We wouldn't be able to put any more circles in there. So this has to be green. But now these 3... I gotta remember to do the counterpart here. Okay. So I can't put one here again in the blue because it eliminates 2 of the 3 options in the 2 region up here, and we need at least one of these 2, so this one can't be. So I can see that if we put one in here, that's going to force one in this up here, because you're going to put across here, which is going to eliminate this one. It's going to force that one. If we put one here, then you could still do either one of these. If you put one there... no, same thing as this green one in the middle here. Right, this cell right here. If we put a circle there, it eliminates 2 of the 3 options. And that's counterpart is in here. So now we've got the... That's nice. So we've got the circle in the 1 region. And we can copy that across. Now we still don't know which one is the other one in the 2. But at least we've got something going here. Now we can look at this 2 region over here, this winding one, because just like our 2x2 squares that we had, we can say that there is at most 1 circle in these 3, because it's part of a 2x2 region. So there's at most 1 in here, which means you have to have 1 up there, because it's the only spot left in that little windy region. So there's 1 up here. Now maybe we can do the same thing. Yep, with the 3. So again, there's 1 at most in this yellow. There's 1 at most in the blue. We need 2. So there has to be 1 in the yellow and 1 in the blue. Now, we can also say, since there's 1 in this blue over here, let me change that blue to red, just so it's less confusing. Since we have 1 in the blue, there can't be 1 there. 1 in the red means there can't be 1 here. Now let's make sure we copy across. This green is over here. Okay, now we can do something similar. I'm running out of colors. Let's do... I'm going to do our red and our blue again, even though we're already using red and blue, because I want to have the purple for the overlap. So again, we've got 1 in the red, 1 in the blue, which means we can't put 1 in the purple. Because if you put 1 in the purple, it eliminates all those. So there's 1 in the red, and now we've got our domino here, so we can mark those. So let's make sure we mark our greens on the other side. So this one is here. It's messing with my head, this symmetry thing, because this red one is actually like these 2 blues and this red over here, and it's a little confusing. All right, so we've got 1 over here. So there's got to be 1. The red and the blue can't be, directly above each other, but I don't know what that really does for us. 2, 3, 4. I was trying to see, so we know in this 3rd and 4th row here, we know there's 1, 2, 3, 4 at least. If we knew there wasn't 1 in the cell up here, then we could eliminate the dashed line here, because you need to have 4, and putting 1 on the dashed line is gonna not have a counterpart, so you're gonna have an odd number then in that area. So okay, yep, more star battle logic. I'll go with orange. This 2 region down here, you have a 2x3 area now. We used to have this also, but now that it's limited to a 2x3, you can kind of think of it as 2 overlapping 2x2 regions. You've got, this one and this one, and there has to be 1 in each of those. So that means there can't be any in that middle. And now we have to have 1 in each of those orange dominoes, which is going to eliminate this cell right here. Let's make sure we do our symmetrical counterparts. And now we've got 1 right here, because it's the only 1 in this domino that was left. Put it across there. That eliminates that. It gives us this 1 up here. Eliminates both of those. Now this is the only 1 in the blue. Look how well that all worked out. Now, do we have 3 in the 3? We have 1 in the 1, 2 in the 2, 2. This is the only 1 left up here now for this 2 region. Good. I think we're doing good up there. Now, this circle here, gray cell, eliminates both of those, which gives us both of these. And now we can mark a whole bunch of not circles. Now, I bet this 5 is going to help us. Let's see. What do we got here? We've got 1. We need 4 more. Yep. Same kind of thing we did on the last one. So we need 1 in the yellow, 1 in the blue, and we've only got 2 cells left. So these have to be gray. These can't be, because there has to be 1 in this domino, which makes the yellow This one can't be by that. Do the symmetries. And now we've got our 2 in here, so that's done. So I think that's the solution for the medium one. All right, we're doing good so far. All right, let's move on to the hard one. All right, and this one has a little bit of a twist. So this one, I can see why this one is marked as hard, or harder, I guess it says. But um, let's start our timer. So there's an example on this one too that I've put on the screen here. This one is symmetric over the diagonal. And so he's added in the letters to make it a little easier. So if you put one in, say, A, row A, column D, its symmetric counterpart is going to be row D, column A. So that just makes it a little easier to kind of see what you're doing there. So I can already tell this is going to hurt my brain trying to see the symmetries. Okay. Where do we start? There has to be one over here. Okay, so similar to the domino thing, if we have a 3x1 region that has to have a circle in it, this is more star battle logic I'm using, we can eliminate the center one on either side. So with the domino, you can eliminate both on either side. But you can see that no matter where we put the circle in here, it's going to eliminate those two. So now that's BE, so right there, right? Yeah, and right there. Yeah, the letters are helpful. That is a little bit tricky to see the symmetries. When I was up here, I was like, well, it's just across the line. It's easy to see. But once you get down in here, that's a little bit less obvious where the symmetries are. Okay. Do we have to map the region? So we know there's one in here. That maps onto this one region over here. I don't know whether it's helpful to mark those or not. I don't know that really tells me anything over here. If all 3 of those were in this hammer-shaped 2 region here, then that would be helpful because we'd know there had to be one there and you could only put one over here, but it's not. All right, what about this one region down here? Okay, well I can see that you can't put it in either of these because you would have to put it in its symmetric counterpart. So, oh, that's interesting. So, I don't think that was the case on the others, right? No, it would only work with the diagonal. With the diagonal symmetry, any region that has 1 can't have the 1, has to have the 1. If it's a 1 region that crosses, okay. I guess it only works when it's a square like this. But the point is, it has to be on the line. Now, this region up here is different because its symmetric counterpart is not going to be in the same region. But, so one of those two, because if you... Oh, is that... Yeah, okay. Yeah, actually, so we can do this because of this, because it's a 1 region, but actually we can do that all the way up here because with Star Battle, if you put one here, it eliminates the one diagonal. You can't have circles diagonal to each other. And if you put one right off of the line here, by symmetry, it's going to have to be on the other side. So we can actually eliminate these all the way along there. All right, that's helpful. Now we know there's one in here. Let's mark that one blue, just which is gonna be there, right? Yeah. So there's one in there, and now but the other one in this 2 region up here, we need 1 in these other 3, but I can't quite see how that helps us because you could put it, uh, this orange could be, and that would be fine. Now in here, in this 2 region that snakes through here, we need to get, we need to get 2 circles in here. And these 3 over here are very clumped together. But I don't think we can quite say, because, if you put it right here, you'd eliminate both of these, but you can still put one over here then. So this one, this one. Yeah, and I can't quite say that I can only do one of these 3, because if I go here, I could do both of those still. So what can I do here? What about this 2 region? I can only do one of these 2. So there has to be one. Okay. Let's do our blue and red and purple again, because I've got 2. So there has to be one in the red, and there has to be one in the blue. And they overlap in the purple. But I can't eliminate the purples, because you could still do the second one and the fourth one, or the third one and the... No, I can't do the second one and the fourth one. Can I? I can. Yeah, I can. Yeah, I can. I don't have to have one over here on this diagonal. I can have at most one over here on this diagonal in this hammer shape 2 region. But I could still do the second and fourth of this, red-blue line here, or the first and the third, or the first and the fourth. So any of those are still possible. But I have to have one in the red, which is how we got these greens, and I have to have one in the blue, so we can put greens here as well. That is going to be these 2. It eliminates some more at least. Can we do anything in the 4 region up here? Oh, I think we can actually. All right, let's go orange and yellow and blue. So, same trick we've been using. You can only put at most 1 in each of these colored regions. And we need 4 total, so that's 3, which means we have to have 1 here. It's going to put 1 there, which is here. Right, that's okay. Wait. Yes, that is okay. I was eliminating a blue, but this was purple, which was part of the blue. So we did end up using the red and the blue, 1 circle to cover both of those. So there's 1 in this diagonal region here. We can get rid of we'll get rid of this. That puts 1 there. Let's make sure we do the other side. This one here, I don't think we did. So now we need 1 in the blue and one in the yellow. Means we can eliminate that one. So that blue is there. Oh, I don't think I can get the yellow yet. Let's see. Have we done all of the updating on the other side? This is CH and CI, so right there. So we can do this. Oh, we're getting close. Oh, this region down here. This 2. We've already got both of them, so this can be green, which means there has to be 1 there. Perfect. So we've got our 4 in here. We've got our 1 in there. Oh, and we've eliminated this one now, so that gives us our second one in this hammer region. And now this winding 2 shape only has 2 cells left, which gives us this one in the 1 region here. And now, and this counterpart there. So now we've got both of them in this 2 up here. What's left? We've got 3. Okay, yep, perfect. So we need 1 in there. No, that's not true. Not true. We could put 2 in here, actually, couldn't we? So, oh, no. No, we've already got 1 in. Oh, we've got 2. We've got 2 in this 3 region already. Look, right here. So that means the third one cannot go in either of these 1x3 areas, because then you would have a counterpart, which would give you 4. So the third one must be on the diagonal there. These must be green. That one eliminates there, and our 1 region gets the corner there. Cool. That's kind of fun. It's I especially like this diagonal symmetry one. That one really messes with your brain, but creates some interesting logic and interactions between these weird shaped regions. That was cool. I like that a lot. I might have to try some more of those mirror galleries. I don't know if he has more on his site or if these are the first ones he's made. I'll have to check it out some more. I've done a few of the puzzles off of his site, but I haven't seen the mirror galleries before, and I haven't done too many of them. I need to go look at some more. There you go. So go check out Jacob Cohen's site, Puzzles for Progress. Try some of his puzzles. Donate to help buy some malaria nets, and save some lives while solving some puzzles. It's a win-win. All right. See you guys again soon.